Okay, so some example problems on the next several slides. I'll go through these fairly quickly. Just more to give you, these are more to give you practice punching these numbers in the calculator and getting the answers. So here's one, an example of the IRR. You put those in the calculator. You should get an answer of 5%. I think you might get 4.99 on your calculator, but that's 5% based on the answer choices here. Here's another question of a project costs $3,000 and you get $800 a year for 6 years. And I asked the question in two parts. First, what's the present value of the future cash flows? So you can do this using the NIPV payment future value buttons on the calculator if you want. N is 6, the I is 10, the payment's 800. That'll give you the present value of the future cash flows. And then to find the net present value of the project, you'll just subtract $3,000 off the present value of the future cash flows. So here's the answers you should get. The present value of the future cash flows is $3,484. When you take out the $3,000 that it costs today, the net present value is $484. So there's just a couple of problems to practice there. We've also discussed this briefly when I talked about IRR, in that it's possible that if you are trying to choose between two projects, I've got two projects here, and if we calculate their IRRs, you'll find that the IRR of this project's 14.29%, and the IRR of the revised project is 12.56%. So you can put those numbers in your calculator and be sure you get those answers. And if you look at if we then go and calculate the net present value of these projects, so what we'll do is calculate the present value. Well, if you're putting these in the cash flow button, here's cash flow 0, and then this one just has one cash flow, and you can calculate its net present value. This one has 3 positive cash flows after negative cash flow 0, but you can calculate their net present values, and the answers are given here. So it turns out this is a somewhat contrived example, but the project with the smaller IRR actually has a higher net present value. And I'm looking here to see if I gave you a... Okay, the interest rate's 7%. I don't make that really clear here, but the interest rate's 7% when you're figuring out the net present value of these. So based on an interest rate of 7%, here's the net present value of these projects. And what's going on here is that at low interest rates, then you're fine waiting on getting this big payment from the revised project. If interest rates are high, then you don't want to wait that long because you would rather go ahead. The initial project pays you a lot of money early on. And if interest rates are high, the way I think about it is I'd rather go ahead and get this money, this $400,000 early on, get it in the bank and earn those high rates of interest than wait on this one. But if interest rates are low, then it's easier for me to wait on money. So since this one's paying me a large payment 3 years from now at low interest rates, I'm willing to wait on it. Right, and that's the difference here. And the whole point of this example is just to say that if you're trying to choose between two projects, make the decision based on their net present value, not the internal rate of return. Okay, and that's what this said here. And here's a chart of the net present value of the two projects, and you can see that the revised projects at low interest rates is higher than the net present value of the initial project, which is the blue line. So the revised is the red line, the initial is the blue line. At some point they actually switch though, and the blue becomes better than the red. And again, I said it's as it is. At low interest rates, you're willing to wait on the big payment that comes 3 years later from the revised project. But as rates get higher and higher and higher, then you're more likely to want to go ahead and get the money that the initial project is going to pay you early. It makes a big payment early. Get it, put it in the bank, and start earning money. And you're better off at high interest rates doing that than waiting on the money you're going to get later on from the revised project. Okay, and so there's as a technical detail here, and I just mentioned this in passing just so you'll kind of have it if any of you guys ever end up really dealing with this in a more serious fashion. It is possible for certain projects to to have more than one IRR, more than one solution to the equation. And that only happens when you have a project that has positive cash flows, negative cash flows, positive cash flows when the signs change. And so you might have a project where you have to spend a lot of money up front to start the project. You run it for a couple of years, and then you have to shut it down and spend more money on it. So one example of this is a nuclear reactor. You spend a lot of money to build the thing, you run it for several years and make money. But after a few years, you have to shut it down and spend a lot of money to refuel it. That's not an easy process because you're dealing with radioactive material. So it's expensive to shut that down and refuel the reactor after you've run it for, I don't know, 10 or 15 years. And so that project has cash flows that start negative, then go positive, and then are negative again, and then go positive again. And just because of the mathematics here, when the signs change, you end up having more than one solution to the IRR equation, and it can cause you to make some bad decisions if you look at that. And it's just another thing that, another reason why you should always make your decision based on the net present value. All right, so people like the IRR because in general it's easy to talk about rates of return. That helps you understand. People like to have that because they have a feel for the kind of rate of return that they want to get. But when you're really making critical decisions, you should base them on the net present value. Okay, so there's our IRR rule. And it does work fine if you're just trying to say, we've got a project and it has conventional cash flows, meaning we invest some and then we get a lot of positive cash flows in the future. And in this case, if the IRR is greater than your discount rate or the required rate of return, then do it. And if not, then don't, right? Now, when you're comparing mutually exclusive projects or when you have these non-conventional cash flows that change signs over the years, just base your decisions based off of the net present value. Okay, so there's a question here. Which mutually exclusive project? By mutually exclusive, it means you have to pick one or the other. Should you pick project A or project B? And so what you'll do is find the net present value of each project and choose the one with a higher net present value. Remember, the IRR wouldn't be a good way to compare these because they're mutually exclusive projects. Okay, let's see, I'm going the wrong way here in my slides. And here's the answers to that. Let's see, project A has a higher net present value, so you would take it. Okay, so let me stop here and we'll finish up about long and short-lived on the next recording.